So we're going to be approaching our elementary problems here in this two-step fashion. And one of the things I want to point out first, when I look at this inequality, absolute f of x minus L less than epsilon, that is equivalent to L minus epsilon less than f of x less than L plus epsilon, which is in a sense saying that f of x is in the horizontal roadway with center stripe L. Notice, whenever you see absolute value, if you see something like, let's say, absolute value of A less than epsilon, that's the same as saying negative epsilon less than A less than epsilon. So this inequality is the same as saying f of x minus L itself is between negative epsilon and plus epsilon, so on adding L to both sides we get this simple inequality. So keep that in mind. When you go to attack step one to solve that inequality, this is generally the best way to go. Immediately replace it by this inequality, and now you have something that you can solve for x. Then once you've solved that inequality for x, then it's easy to find a delta, because as soon as you've located the interval AB, you just choose delta to be the smaller of the distances from x naught to either end of the interval. Now we're going to begin with a problem where epsilon is given and the function is given, and we have to find the delta. Suppose f of x equal 1 over x, L is 1/4, and x naught equals 4, and epsilon is equal to 0.05. What we want to do is first find an open interval about x naught on which the inequality absolute f of x minus L less than epsilon holds. So that's our first step. We want to solve that. And then once we've solved that inequality, we want to then find the delta greater than 0 so that 0 less than absolute x minus x naught less than delta actually always implies that f of x minus L, an absolute value, is less than epsilon. And we want to do that for this very particular setup. This function, f of x equal 1 over x, we want the x naught equal to 4 and the L equal to 1/4, and the epsilon is 0.05. Okay, so that's our problem. So f of x is 1 over x, L is 1/4, x naught is 4, epsilon is 0.05. Now that's 5/100, which is a 20th. And so the initial inequality that we have to solve, absolute f of x, is absolute 1 over x minus 1/4 in absolute value less than 1/20th. So that's the same as negative a 20th less than 1 over x minus 1/4 less than 1/20th. So add 1/4 throughout, we get 1/4 minus a 20th less than 1 over x less than 1/4 plus a 20th. Now 1/4 is 5/20, so 5/20 minus 1/20 is 4/20. So we have 4/20 less than 1 over x less than 5/20 plus 1/20 is 6/20. Well, 4/20 is clearly 1/5, and 6/20, we can cancel 2's, is 3/10. So what's happened now, our inequality is simplified to 1/5 less than 1 over x less than 3/10. Now, all our numbers here we can assume to be positive. So consequently, I can turn everything upside down if I reverse the inequalities. So this inequality is equivalent to 5 greater than x greater than 10/3. Let's reverse the inequalities now and put it in the order we're used to. 10/3 less than x less than 5. Okay, well, what is 10/3? 10/3 is 3 1/3 less than x less than 5. Where's the center we want to look at? X naught is equal to 4. So see, here's the solution of our inequality. 3 1/3 less than x less than 5. The center of our interval we want to look at is at 4. And so what would be the center, what would be a delta that'll work, that 4 minus delta to 4 plus delta will stay in this interval? Well, what you do is you look at the distance from 4 to 3 1/3, that's 2/3, and the distance from 4 to 5 is 1. And so delta has to be the minimum of those two distances. And so the minimum would be 2/3. So consequently, if I take delta equal 2/3, let's write that down, delta equal 2/3, then we'll have solved the problem. In other words, in this situation, take delta equal 2/3. In that case, if 0 is less than x minus x naught, where x naught is 4, is less than 2/3, that implies that f of x minus L is less than epsilon, where f of x is 1 over x and L is 1/4. All right, now let's look at another problem with epsilons and deltas. Here, I have the function f of x equal x squared, L equals 4, x naught equals -2, and we're taking epsilon equal to 0.5, which of course is 1/2. And so we want to solve the inequality f of x minus L in absolute value less than epsilon. Well, that inequality in this case becomes absolute value of x squared minus 4 in absolute value less than 1/2. And so consequently, that's the same thing as saying -1/2 less than x squared minus 4 less than 1/2. Now add 4 throughout. We get 4 minus 1/2 less than x squared less than 4 plus 1/2. 4 minus 1/2 is 3 1/2, or 3.5. Less than x squared less than 4 plus 1/2, or 4 1/2. I'll write that as 4.5. So here, we've just about finished. Notice taking square roots will preserve the order. That is, if I take the square root of each of these terms, then square root 3.5 is less than square root of x squared is less than square root of 4.5. Now, what is x naught? X naught is -2. So consequently, our x naught squared is 4, and the square root of x naught squared is 2. So that is in this range. On the other hand, one thing that we need to keep in mind here is that when I deal with this inequality, it could be that it's the negative square roots we want to look at.